Good morning, everyone. So full disclosure, this is the first time I've ever done anything like this, so don't throw the oranges at me quite yet. I'm very excited about this topic because I'm a nerd for any technology that gets people data and allows them to see the things that they don't really realize what's going on in their systems. So this morning we're going to have Joe, who's going to be speaking about a project in Sandy, Oregon, on how a small utility uses technology such as smart metering and leak detection and pressure monitoring to efficiently manage their distribution system. And then we're going to hear from Patrick Williamson. He's going to discuss an opportunity that occurred in Ocala, Florida, where by using AMI and sensor technologies, the utility was able to identify and respond to abnormalities within their system. And then finally, we're going to hear from Rob King, who's going to talk about the advancements in acoustic fiber optic monitoring in pre-stressed concrete pipe, so that a utility can reduce their operational risk and maximize the life of their pipelines. So with that, we're going to start with Joe.
Good morning, everybody. All right. Starting off with the City of Sandy, we have partnered with Mueller in a project. A little bit about Sandy. We're located about 30 miles outside of the Portland area, kind of between Portland and Mount Hood. We have about 2 million gallons a day of water we get from our Alder Creek, which is Sandy's main source of water, and that's about at half capacity. We did get almost 500,000 gallons from Brownell Springs, which is Sandy's original source from 1924. And it gets regulated down, in the summertime with junior rights that are below us. So it gets regulated down. Then we buy a contract minimum of 500,000 gallons from the City of Portland, which this last year we've been able to turn it down to about 200,000 gallons a day. With our unique problem, we have the Portland Water Bureau moving its water filtration plant downstream of our connection that we have right now. So we're working through ways to make sure we can kind of eliminate our water loss and use the technology to help find things and keep our water usage as low as possible. In collaboration with Sandy and other partners, we devised a vision to outfit one of our neighborhoods, which is we call Zone 4, with the best smart water technologies available. Our goal was to see how far we could push the technology to targeting a 0% water loss. We can really start breaking down what we can see and trend out to find water leaks. And then we can go through and see the consumption trends as we work through this. Project includes the following technologies from Mueller. We went through and had a full system AMI replacement in 2020, and then that was about 4,100 water meters. Our AMI water system also with this project had the insertion meters with mag meters that were going through and counting all the water into the DMA for this one pressure zone. We also use the EcoShore acoustic leak detection deployment on 51 fire hydrants to listen to the water system in that DMA. And then we also have the I2O pressure management, which includes the remote pressure loggers and controllers. The Singer pressure reducing valves were what controls the water into this pressure zone. The existing system layout, there was 2 vaults that fed water into this DMA. One was our Bluff Road vault, and then which contains a 2-inch and a 6-inch PRV, and our Starbucks vault, which contains a 3-inch and a 10-inch PRV. That's located at 2 different elevations. Should be oh, there you go. There it is, right there. Thank you. The smaller 3-inch PRV at the Starbucks vault controls the pressure in the system, and the larger 10-inch is set at a lower pressure as the bypass line. There should be, if there ever is a pressure drop at the location, then the others take over. All right, go to the next one. There you go, thank you. From here, from left to right, we can see I have an insertion meter and its controller that we're getting ready to install. We went through, there's Jason in the middle on the top that was going through, and he was installing and testing the DX leak detection EchoShore systems on the hydrants. And then we were looking through some of the bottom one there, we're looking through some of the data as we were installing everything and seeing what was coming live and what we could see at the time. And then the picture on the right is the actual I2O pressure controller for the adjusting the pressure. Next. That's okay. Oh, back one more. There you go. Okay, so on this one, left to right, we have the I2O pressure monitor unit that actually has looking at the pressure in the zone. The center one there is the Singer control valve that modulates the water into the zone. And then there's the insertion meter again. And then the mag meters that are actually counting the water on the bypass lines. Next. Okay. Before and after the pressure step test, pressure downstream of the PRV was reduced in 4 steps from 55 to 39 psi. In this chart, it shows that as one drop over a 24-hour period throughout the zone, we had no complaints during the test, but it exposed a lower limit in the pressure zone that we needed to consider for the optimization of for the future. The next step will be to perform more tests in the pressure zone as the monitors are deployed and get the highest elevation points in the system so we don't lower the pressure too far. There it is. As you can see on the left, this is the display on the Centrix Mueller software platform. It shows the strength of the leak over time as an acoustic level, which is set above the red line. It shows, you can see that it was identified in early November of 2023, then was repaired on November 22nd. So we were able to here we had a problem throughout the technology. We went out and used our listening devices. We found the leak in the area that was only a couple feet off, and we were able to find the repair. Following the repair, we tracked the water loss into the area using the meters of the DMA. The data indicated that the following repair of the leak, water usage in the zone dropped from 318 feet per hour, or cubic feet per hour, to 255 cubic feet per hour, equating to a leak of 60 feet, or 63 cubic feet per hour, which is about 8 gallons a minute. The EcoShore leak detection system provided an estimate of the leak and estimated between 5 and 7 gallons per minute. So we were able to get really close and see that the technology was really seeing what we found on site. And here's a small video of the water leak that we were finding. I have to go back one more and then forward. Maybe? There it goes. So what you can kind of see there is we're standing on the asphalt, and then below the asphalt on this road, there's about 6 to 10 inches of CDF. So basically, it was pretty strong. It felt like they just poured cement down there. So the acoustic information we got from the sensors listened underground and was able to pinpoint it. And then what we found on top is we were about a foot off from what the detection equipment was saying. And it was off because there was a hole cut in the concrete, excuse me, in the concrete that was throwing the ground, the surface level noise off a little bit. So, but the EcoShore data pretty much pinpointed it right to where it was. So it was nice to find. Let's see, I think we're, that might be it. I thought there was more on the north side. But I think that's all we have. All right.
And next, we're going to hear from Patrick.
All right. Y'all can hear me okay? Let's see. All right. I'd like to thank SWAN for having us here today. Appreciate this opportunity to be able to talk to you all about this project that we had with the city of Ocala, Florida. So with Ocala, Florida, we were able to work with their operations team and the customer service team and billing teams on this project and taking their AMI data and setting up event monitoring to be able to look for different anomalies in their system and be able to help them be more efficient in their process. So Ocala, it is in Florida. It's about an hour north of Orlando. It is an electric and water utility. They have over 28,000 services, water services in their utility, and they've been using AMI for over 10 plus years. Their current system, though, now with AMI is a cellular-based system that does 15-minute interval data points. It communicates several times a day, and it puts the data into their SaaS product, the SaaS platform. And in this SaaS platform, that's where the event monitoring, the data analytics, and all this is being set up by the actual operations teams, billing teams, and things like that, not needing additional resources outside that group to do this. Is a scale of some of the data that they have on a daily basis, monthly, and annually. So over 1 billion data points every year are collected through the system, monitoring flow, pressure, temperature, and water quality. And they're doing different kind of event monitoring off of that. We categorized this into two different categories for event monitoring. First, we had individual specific locations or critical service points. An example of this is even the individuals themselves. Their customers have access to an app where they can monitor their own consumer usage and even set up their own event monitoring, their own leak alerts, and get text messages and things like that. But also critical services that the operations team want to monitor, like hospitals, sporting event locations, or even schools, making sure continuity of service was there, so they didn't have any downtime. And then the second event monitoring category was groups, kind of looking at a broader range. You know, things like residential versus commercial, you're going to look at those differently. Those meters are different sizes, or pressures are going to be different, and things like that. You have different ranges, so you have to set those up differently for residential versus commercial. Other examples were reclaim versus potable, and billable versus non-billable. So what can be monitored, right? There's a lot to be monitored. We've been talking about all this data today that's being collected by all these systems, so you gotta have to kind of pick and choose what you want to look for. And I love this quote of, what gets measured gets managed. Very applicable here, right? So Ocala, this is what they decided that they were gonna focus on. Now, I'm not gonna be able to go into a lot of details on each of these. We'll go into 3 of these that focus on water loss in the next couple of slides. But to give you an example, with reverse flows or backflow monitoring, you know, they were looking for things for cross connection or health issues, right? Or how are my backflow preventers working on my commercial accounts so they could keep an eye on those. Potential pipe bursts or intermittent flow. You know, that's what they were looking for things. They kind of picked the time frame about 6 hours to 24 hours. They were looking for high volume events that happen quickly that they could react to without having to wait or get a call in from the customers. And then water pressure, high and low water pressure. You know, if you got, even in Florida, yes, it gets cold in Florida, and we can have freezing conditions, especially where Ocala is, a little bit more north there. We don't bury the pipes as deep as maybe the northern folks do, so we got to keep an eye on this thing. So they would set up low temperature alerts, looking for those things for potential pipe freezing. Also, water temperature, looking for a high temperature or low temperature. You know, on the high side, why would you want to know that? Well, for them, the high side, you know, the more hotter the water is, the more the chlorine residuals get eaten up. So this was an early warning system for them, an indicator that they might have an issue in this section. Water quality. Now, this is an area where you can look on the water or wastewater side. You can apply this to a lot of different variables depending on your sensors and the data being collected, like pH, turbidity, chlorine residuals, a number of things that could be used in this that you could set up event monitoring. And even some of those devices, you can set the event monitoring on the device itself. So it doesn't wait for its next call in. It tells you immediately, I got an issue that's critical, we need to address it. Asset health, things like, are my meters sized properly? If there's overflow or max flow going over these meters, it's going to wear them out, plus also you're losing water, accounting for water, your non-revenue water is going up. So, and then asset misconfigurations. Yeah, we are humans still, we make mistakes, and we may have some typos, maybe put the wrong resolution or something like that, and you'll be able to identify issues that may give you misflow calculations, right? You'll be able to identify those quickly. All right, for the next three, we're gonna go into a little bit more detail on those. Leak detection, vacant account usage, and irrigation usage. So leak detection, like death and taxes, we all have leaks. There's no getting around it. It's always gonna be there. So for them, they actually ended up breaking these down between like residential, commercial, and even operational event monitoring. That's how they wanted to break these up and look at them in different ways. For them too, is anything that was an active event alarm that showed up, those were something that they wanted to take their critical resources, they had limited resources like most utilities, and they wanted to be able to attack the higher problem issues. And so those alarms were the ones that they were acting on quickly. Now, when they were setting up these event monitors on these systems, looking for leaks on these meters, they ignored the continuous flow services because they didn't want to have false positives, or I like to say chasing ghosts, right? They wanted actionable things that their team can go fix. So they ignored those in these event monitors, but they still wanted to keep an eye on these. So they did set up different event monitors for the continuous flows just to make sure they didn't get out of hand. All right? And then they were able to use this history of leak information to be able to help them for future planning, for infrastructure needs and things like that. And also help with customer service. They could deliver better customer service when the customer's called. They could help them out and explain what's going on. And on the left-hand side, you'll see an example of how they could set up these event monitors. It was a very simple GUI, point and click. They didn't have to have external resources or IT have to get involved in this. They could do this on their own. So if they had hunches, those gut feelings that you might have had, right? I know something's going on, I just don't have the data to prove it. Well, this was easy for them to point and click and figure out and collect the data to prove what was going on in their system. Vacant account usage. If you don't keep track of your vacant account usage, that's going to add to your non-revenue water, right? Prior to this system, they used monthly billing data to look for this. So they were able to keep on top of it. Within a month or two, they would be able to find out if a location had an issue. Now with AMI data coming in near real time, it was within days or within maybe even hours, they were able to correct issues. And this is one of those where event notifications made sense of sending like a text message or an email to the billing manager to find out what's going on and looking for these issues. As you can see on this graph below, it kind of trends tended to go over time. So they used a lot of graphs on here to see how are they doing, how are they trending, are they improving? And that's what they were able to use here. One little side benefit to this too as well is kind of a secondary QA check of how the billing team was using the CIS system. Because sometimes paperwork didn't get processed in time, work order didn't get processed or something. They were able to catch those issues here. Irrigation monitoring. I think the Phoenix folks were talking about that earlier, about being very resourceful here. In Florida, we have water management districts that set guidelines. So Ocala belongs to the St. Johns River Water Management District. They set up the guidelines for irrigation and other water conservation goals that the utilities in their district need to try to achieve. Now, prior to this system, the way that they would monitor irrigation usage was pretty much through proactive education to the public, monthly reporting. So it wasn't as detailed as they would have liked. So now they ended up setting this up. So now they were able to find patterns. Because they really wasn't looking for the one-offs, because you could get those confused with maybe filling up a pool or a known water leak. So you're looking for patterns over time, looking for repeat offenders. And they were able to identify those. But at the same time, they didn't want to just catch the bad. They also want to catch the good. Are my programs working with the public? Are they following the rules? So in this dashboard here on the right, they had the good ones and the bad. So they could see the whole picture. And now they had more information that they could maybe change their education or notify folks and address those issues sooner rather than later. Again, this is something they will do on their own without having to get other third-party resources involved. Okay, finally, to wrap this up, some observations and lessons learned. Start with why. Honestly, I think every business decision, anytime you're addressing a challenge, why am I doing this? That is the question you ask. What is the goal I'm trying to achieve? Just as a side note for me, one of the best books I ever read was from Simon Sinek, Start with Why. It's a great topic to go into this conversation. And then using a funnel approach here. Start with a wide look at the data. So you can see what kind of data range am I getting? What's true versus not, which is false? What do I need to actually have actual intelligence on? And so you can narrow that down over time. And this does require ongoing refinement. You know, you can use the PDSA Deming model between plan, do, study, and act, right? You can follow that and refine it over time and build that into your culture. What we ended up finding here is we found other issues we weren't necessarily looking for, but it got caught in the net, if you will. You're going to find things like older meters maybe reaching end of life, or admin setup issues. But we were talking about data, garbage in, garbage out. You know, you got to make sure the quality of your measurement devices are accurate, maintained properly, and also the data is being delivered efficiently. Because if you got bad data or delayed data, you're not going to have good results from any of these event monitoring or data analysis. Consider timing. Seasonality is an issue, can be an issue. Got projects going on or other things going on. Ocala, for them, they have a snow bird population. I'm sure Phoenix, they have that too, right? That affected the seasonality of their data, so they had to adjust for that in their event monitoring. Additional data points, CIS, GIS, asset management, anything that's of quality data that can simply get in there, that could help you refine your monitoring even more and be very specific. Integrating with your other systems or work order systems, you definitely encourage that. APIs, even a simple email can be used as an interface. You know, your IT folks should be able to help you with those kind of things. Automate notifications on critical events only, meaning if I got an event monitor in here, I can send email notifications and text alerts. Well, I don't want that for every single little 1-gallon leak in the entire residential system because that will blow up my email box. I need to be very specific. Like an example, the vacant accounts. That's something that doesn't happen very often. Now, when they see those come in, they see it and they can address it. They don't even have to go into the software. They can take action right there. And then finally, using these event monitors can be helpful in extreme weather events, maybe hurricanes or blizzards or other disasters. That'll help you use your resources effectively in those critical times where you can get the most bang for your buck and address the important issues. Amy?
Thank you. Next, we have Rob.
All right. Thanks everyone for having me here and for being here today. My name is Rob King. I'm here to talk about acoustic fiber optic sensing, and specifically recent pilots that we've done to enable leak detection on existing systems. And so if you heard me say about there and the first thing you thought is this guy's not from around here, you're spot on. I'm Canadian. I joined Xylem about 13 years ago in our Calgary office. First week on the job, I found myself in a hot, humid pipe in Texas, pulling fiber optic cable, thinking, you know, what in the world am I doing here? Lo and behold, I'm still kicking around. Most of my time at Xylem has been related to this sensing technology from, you know, one way or another, whether it's on the back end or whether it's installing it in different installations, different pipelines around the world. So to start with, we'll just touch on why does this technology exist? It's really a technology that's targeted at large diameter transmission mains, specifically pre-stressed concrete cylinder pipe. And the bottom line is when these pipes fail, they make a big mess and they cost a lot of money. Some of you might have heard about a failure in Calgary last June. I think the city attributed about $20 million in direct cost to that failure. A study in 2017 found that direct cost is typically only a third of the total impact when one of these pipes fail. That same study would indicate that that Calgary failure was very large, and $12 million is a more typical or average cost for that type of failure. So when you own these large pipes, what do? You can replace the whole thing. That's really not, technically or economically viable to just replace, the whole pipe every 5 years or something, and you still have a big pipe to manage. You can do nothing and hope it doesn't fail. Fortunately, like these failures aren't really all that often, but that's a bit like playing Russian roulette. And if something goes bad, well, it goes really bad. And then the last option is you proactively manage it, and that's where routine assessment and various solutions come in, like this monitoring solution, designed to basically get more pipeline life for less total dollars. This solution's been commercially available for about 20 years, specifically targeting wire break detection on pre-stressed concrete cylinder pipe. For anyone that's not familiar, the dominant failure mode of this type of pipe is broken pre-stressing wires that make up basically the entire structural capacity of this pipe. 2008 EPA study pointed to those pre-stressing wires in about 80% of all failures. There is another 20% of catastrophic failures that they attributed to leaks, which is part of where our motivation is coming from to expand the capabilities of this monitoring system. Overall, it's actually performed really well over the years. There's lots of pre-stressed pipe in the ground that's still 70 years old and has extremely low levels of distress. What inspection data tells us is that less than 1% of the pipe typically needs immediate intervention or immediate repair. And the other, say, 3 or 4% that does have early signs of damage can typically be managed for many, many years into the future rather than undertaking a huge rehabilitation. Over the past 30 years, there's been a lot of technology that's been developed to manage this. There's a whole chapter in an AWWA M77 manual dedicated to how you can manage this pipe, and if you follow those best practices, the chance of an unexpected failure is virtually eliminated. Part of that toolbox is this fiber optic sensing system. And in this fiber optic sensing system, we're turning a fiber optic cable into a microphone. If you've got 10 miles of pipe, it's kind of like lining it up with 15,000 microphones all along it and listening for the sound at every 3 feet along the way. The origins of this actually date back to the early 90s. Acoustic wire break detection work being done by the U.S. Bureau of Reclamation on one of their large pipelines using hydrophones. And my company's commercial origin of this actually started in buildings, detecting breaks in pre-stressed slabs before being deployed in water pipelines. So today, the cable, it's unanchored in the pipeline. There's a data acquisition system constantly listening, processing acoustic and location data that gets pushed to the cloud, where there's a combination of automated and human analysis that gets done before posting the results. It's always been wire break focused. Now we're expanding it and working on its capability to also detect leaks. So our approach to doing this, we're using the same fiber optic system, the same back-end infrastructure that's already installed out there with some computer upgrades along the way, but we're using a different data processing method. And so instead of looking for these wire break events, we're taking periodic recordings. In this pilot, we were doing recordings every hour, and we're looking for changes in that baseline over time. How's the acoustic energy of that pipeline changing? And so the y-axis that you would see on this graph is actually talking about that, or is describing and capturing that acoustic energy, and the x-axis is looking across about a half-mile section of pipeline. All the different squiggly lines are the acoustic energy that was captured at those various points along the line when we sampled the data. The top 3 lines there, where there's a little bit of a jump up next to the arrow, about a 20 dB change in energy, those were recordings taken when we were simulating a leak at a location. And so it's that difference in energy, that change in energy that we're looking for to identify the leaks in the system. The principle, at the end of the day, is pretty similar to, how a correlated would work, which are proven quite well to work in many pipelines out there. The difference being the fiber's always within a diameter of the leak source with this system. So for the field trials, what we were doing is we were using calibrated fittings to open up and create a simulated leak at different locations along the pipeline. And we did field trials at 4 different locations, pipeline diameters of 36, 66, 54, and 42 inches. I apologize, there's an error on the slide there. There's reference to 60 inches that was not completed. So just ignore that. And these distances were varying between about 5 and 8 miles away from our data acquisition system, and pressures ranging between 60 and 100 psi. So we learned a lot through this phase in terms of understanding how does that ambient energy in a pipeline change, that acoustic energy change when you're beside a valve, when you're beside a bend. Perhaps they're close to a pump station, far from a pump station. And we also learned a lot about, okay, well, what do these leaks sound like? Critically, like a loud leak can actually be kind of quiet, and a small leak can be really loud. And so, we successfully simulated and detected simulated leaks down to 5 gallons per minute at these locations. Our experience, and as we build that experience, it tells us there'll be many cases where we're not going to find 5 gallons a minute. If you've got a lot of background noise in that section of pipe, it's not going to stand out above that background noise for us. And we expect or anticipate that a more realistic, high confidence detection threshold is probably closer to about 10 gallons a minute utilizing this approach. And then lastly, kind of unexpectedly, during the testing, we actually, there was a burst event on one of the pipelines that we were monitoring. And so in this case, we actually identified a change in the acoustic energy, a very sharp, very loud change in acoustic energy, and notified the client, or actually asked the client, hey, is there something going on at this location? Are you doing some construction work? They weren't aware of anything. They went out to investigate, and what they found was actually a very large leak that ultimately, when they investigated, was a 8-inch corroded blow-off that had failed suddenly. So what's on the screen here is simply an acoustic profile of the line before that event happened, and an acoustic profile afterwards, and that big bright purple band at the end of it, about 8 miles, I think, down from the data acquisition system, is indicating that burst. So this was a great win, an actual leak as opposed to just simulating through the pilot period, and it's an important lesson, I think, that we're taking as we look to think through the different operational workflows that we need to have, and perhaps report a little bit quicker than we had, do so today with our existing system. So, thank you. Back to you, Amy.
Okay, so I'm going to ask one question of all the panel, and then I'm going to open it up to the floor, so get your questions ready. As a panel, if you guys could answer, what were some of the biggest challenges that you didn't anticipate during your pilot? Joe, you want to start?
I think some of the starts of it was just trying to, as a smaller utility, and there's about 15 to 18 of us that take care of 4 departments, pardon me, and there's about 2 of us that take care of just water. So taking the technology and having people to start dedicating the time to it was nice to have the information there that we could actually start doing something with and being a little more productive with the small amount of time we have to deal with the water system. So it was able to just be able to sit down and start taking in the data that we had and being able to be a little more strategic on getting boots on the ground to take care of issues and like we said in our slide, finding the service line leak that we had.
Patrick?
I would say is what was the focus on?
that was with the event monitors. You saw I had a whole laundry list of things that they ended up doing. They didn't start day one with that. They had to kind of pick and choose. The ops team was like, okay, I want to focus on some of the leaks and the reverse flows and catching some of those things. And the billing and operations folks, they liked some of that information that was coming from what the ops teams were doing, but also the vacant account stuff. For them, that was like, okay, I can be faster with this, and I can resolve these things quicker. Those were the quick, easy wins for them. And then just kind of getting through that data, refining it to see what was actionable. That, because you cast a big wide net first, and then you kind of narrow it down. That was the challenges.
Rob?
Where to start? No, I think, one thing I guess I'll say with these systems is the actual installation can be a challenge quite often. We were fortunate to be doing this pilot where the system was already installed. So that simplified things quite a bit and probably made the data processing side of things the most challenging. So these recordings are about 10 seconds a piece when we're doing them. And we're capturing about 2 gigabytes of data or so. And so we have to find a way to chomp that down, do some kind of pre-processing on site before we send it up to the cloud for further analysis. And we also learned, to detect the smallest leaks, we have to have multiple baselines that we're comparing to. So, whether it's some sort of daily operational baseline, whether it's some sort of, maybe weekly or monthly seasonality in the line. Again, being able to manage that, let's say, identify that change from that baseline without creating a whole bunch of false positives was definitely a steep learning curve.
Are there any questions from the audience? Oop. Jeff?
I'm coming up behind you with the microphone. Where did I see some hands?
Where was the hand? Oh, there.
Really exciting to see all of the data coming out of your pilots and all of the studies. My question is sort of pulling forward some points from this last case study looking at specific types of pipes and the acoustic signature on those leaks. What I started thinking about was the sort of spread of what those acoustic signatures would look like with the different types of pipes. They're talking about, I know in some places we still are working with wood pipes or sections of brick, for example, in Boston or someplace like that. So what I'm wondering, especially as we're looking across what you all are doing, it seems like, especially as you're developing machine learning methods, you're going to be needing to pull data from a lot of different locations and be constantly updating those models. How are you gathering data from across those different domains? Because I see a lot of data being used within single utilities or within single domains. That means that we're actually not gathering a lot of sort of standardized or benchmarked data for things like acoustic detection across different types of infrastructure. So I'm just really curious to hear what all of you are doing in terms of thinking about how you're integrating data from different types of systems to be able to, for example, develop benchmarks or classification systems for your machine learning.
Rob, you want to start?
Yeah. Okay. Yeah. Absolutely. You see. I think we're probably in the early days, kind of going down that journey of trying to learn all these different characteristics that you're looking for. Certainly picking out specific frequency bands is a critical element, I think, of being able to process this data. So far, we've really only looked at this pre-stressed concrete cylinder pipe where we have these existing systems. But we are cheating a bit, I guess, maybe, because we also have a leak detection, inline leak detection smart ball, where we have leak data that's being captured over the years that we're kind of referencing to inform, okay, how we're targeting these different things. Unfortunately, I think one of the things that's told us is that, like I said, a really big leak can actually be kind of quiet, and then a really small leak can actually be kind of big. And in fact, the leak path matters quite a bit as well. So, for this pilot, that calibrated fitting, you might have noticed it was kind of a full cone spray. It's calibrated fitting that you would use for like a pressure washer, for instance. Admittedly, it's a bit of an idealized fitting to test on. We've also tested with just simply half cracking a valve. We've also tested or seen where a metal feature leaking as opposed to a pipe. These are all different things. And it means that you have to have a pretty comprehensive strategy of all the different things you're looking for. You can't just cherry pick, that certain signature that you found in the lab, let's say.
While the case study I was talking about isn't exactly related to what you're talking about, but I can talk about other case studies, if you will. For what we've seen is the ability to be open with your data, to be able to accept those. And I know some folks were already talking about APIs and being able to have those and pull that data in. I know with the pressure monitoring systems and acoustic leak detections that we have and our customers have used, like for example on the acoustic side, there is a hydrophone, similar to what he was talking about, and it's listening to the water column, not the pipe material. So the pipe materials has an impact, not as much as you were listening on the material, right? But you build up a library classification over time, right? And then what's nice is then that can be shared across the board, depending, and you need additional data endpoints from like the GIS systems. They got to be accurate. You got to know the pipe materials. You got to know where things are, where those bins are at, and all that stuff, because that does impact the analysis that's going to be done by the system. But being able to display that data with multiple data points, even if it's not captured by your system, right? Maybe a third-party system, or that you're pulling that data in, but you can overlay those together, and you can see the true story, right? Paint that picture.
So as a water utility that's using some of the technology, we've been able to identify with our GIS systems to be able to have a typical trend of that material type that the acoustics are listening to, but then being able to use that to go out on site and check some things to get maybe a normalcy in our water system. But as we see some of the outliers or different changes with on-site checking with correlation listening to quantify that, okay, yeah, that one matches this one, okay, I think we got something to start digging up. So it's nice as a user to have that provided through Mueller in the Centrix program, that data gets looked at for us.
So I think that's all the time we have for questions. So, no, you're good. I believe, thank you very much to all the presentations and the panelists.
Thank you so much to the panel and to the presenters, the moderator. One more round of applause for that group. So I'm excited to announce the next thing because it's lunch. But first, I'm going to turn the time over to our lunch sponsor, which is Arcadis, excuse me, and turn some time over to Esteban to leave us with a couple words.
Thank you so much. Always good to be freelance. I just wanted to say a few words. I hope you guys are as excited as I am for this workshop. This is my hometown, and the amount of insights I've learned this morning are amazing. From the importance of educated leadership that makes things happen, like Ed Gallego, to wholly reminding us that we are a smart industry and can make things happen, as well as the importance of having a plan and keeping an eye on the human component through things like organizational change management. Dr. White showed us that innovation is a path to solve some of the problems, and I really like what he did when he said innovation is not just the data and the technology, is being at the table when we change the regulations or adjust them, is the community, which also connected to the land acknowledgement discussion. So all great points to keep in mind, and Jenna, you mentioned, so what is the call to action, right? I got a few for me, and I think we all need to socialize these things. I'll just say the data discussion was awesome, and to me, the takeaways, there's tons going on, but you can see how quickly we are making things work. The use cases are becoming more real and more valuable. That's going to increase. There is also tons of research going on. Michael, you mentioned a Water Research Foundation. If I don't say this, my colleague Jim Cooper would get mad at me, but I think he's told me there is like 4 ongoing research projects right now highlighting artificial intelligence and how we are going to be able to apply it. So since I won't remember those, talk to Jim Cooper as part of the networking. Before I highlight the next panel discussions, think about data governance. I cannot agree more with the importance of how do we organize this, right? How do we boil the ocean? And I think we are going to be hearing more in the upcoming months and years about the importance of establishing a formal data governance. This is not new. The financial industry has been doing it, but it's a huge change management challenge. So keep that in mind. And again, the roundtables, they're going to be great. There's great topics from cloud versus premise. I think that was one of the things was discussed. There is one that my colleague Edgar is going to be talking about in terms of collaboration, and goes back again to Dr. White. The problems cannot be solved as a standalone utility, and I think the Phoenix area with the city of Phoenix leading is a great example of the coalition that is being built now for the DPR facility. So my last ask from you guys, if you haven't seen it, we have a great initiative going on. We call it Hey Sally. Gets me really excited because what it is intended to socialize the best kept secret, which is our industry. And we want to do that by letting practitioners like us answer questions that have actually been identified by children. And it is amazing. You can stop by. They'll ask you a question that, again, comes from a child, and you'll have to answer it. It's very insightful to hear that. I think, again, we can use that to pump up the volume on water, and also we are influencing in a positive way the generations. So that's it. Thank you so much. Enjoy the networking, and great to have you all here in Phoenix.
So lunch is right outside where coffee was. Maddie or Shayna, is there anything else that we need to say with lunch?
No, just enjoy. There's a lot of
Perfect. Enjoy.